purple color. Okay. Let's read the question first. Suppose that the charge density of the spherical charge distribution shown in figure, which is this figure now, okay, is rho r is equal to rho naught r over r capital. Oh, that means the density or the charge density is changing with respect to r, small r. So as we move from the origin, okay, the density is increasing, okay, until it reaches the maximum, where r small should equals to r capital. Okay, so and this part is very important. Okay. When r is less than r capital, we know that the rho is not constant. And when r is larger than r, the r small is larger than r capital, in this case it is zero. ايش هذا اللي زيرو؟ هي rho equals to zero. Why rho equal to zero؟ لأن بكل بساطة ما عندنا شحنات خارج الكرة. الكرة محدودة بالراديوس r. Okay. So we have this ball here. على فكرة this is very bad ball. So I will make a very nice ball, which is can be, it's not a ball, but so in a circle now. Okay, that's fine. Let's use purple color, but I want to reduce the size of that one. So let's not go with that one. Okay. Okay. Now we know we start from zero here. As we are going outside, we are moving with volumes actually. Okay, so we'll make a small sphere here and then a larger one here, okay, until we reach r. By taking these small volumes of the spheres, so we are taking these charges or the charge distribution or the rho, okay, of that sphere, and then we increase bigger sphere until we reach the far ultimate or the far large radius, which is r capital, which is in this case, this one is r capital. Okay. Okay, what is after r? Nothing. There is nothing here. Nothing. So we don't have charges here outside. All the charges are within, contained, encapsulated within that sphere. So this is why rho is zero outside the sphere. Okay. That is clear. Why you are explaining something clear? I know you are engineers, but this is, I'm just trying to, refresh your mind. Maybe you want to sleep. Okay, obtain an expression. The question now is coming. Or expressions, it's not one or two, for the electric field, both inside and outside the distribution. So they are looking for E inside the sphere and outside the sphere. Inside the sphere, that means r is less than r capital. And outside the sphere, r is larger than r capital, like here. Okay. So let's find E here. So what is E? Okay. What is E here? Okay. It is the same thing, which is the Gaussian method. Okay. So we are using the Gaussian rule or law. In this case, we have phi of that Gaussian surface. It should be equals to E. Now I'm looking for Gaussian surface for a point which is larger than the original surface. Okay, what is the shape of the object? It's a sphere. So if we have a sphere here, which is this large one here, you see? So this is the purple color. يعني هذا اللي تشوفوه بالشكل البيربل هذا. This is the original sphere now. إن قبل شوي نتكلم على original إيش؟ cylinder. Now we have original sphere. Okay, which is in purple color. Okay, it has the radius r مثل ما أنتم لاحظين كذا. Okay, and he is asking, or the صاحب السؤال, he is asking a question: what is the electric field here? Any point outside. Okay, so we'll say we will draw for you an imaginary, again, surface that makes all the electric field lines or the electric field intensity is the same or uniform at that Gaussian surface. Okay. This is why we are drawing the same sphere. يعني حتى هنا راح نرسم أيضا كرة خارجية وهذه الكرة راح تكون imaginary تخيلية. So this imaginary sphere, it should be okay surrounding perfectly the original sphere. Okay. Why is that? To make the electric field here, any place here, or all of these Gaussian surface is the same electric field. Okay, so now the question, what is the surface of that sphere? نحتاج إلى سطح الكرة. Okay, so the surface of the sphere. And this is important to know the surface of the sphere because you are going to use it also. And the surface of the sphere, as you know, it is just 4 by, okay, which is well known for you, 4 by r square. Okay, I think it's clear that is. في حد عنده سؤال ولا في كلمة اسمها صوت؟
4 over 3 by r cube.
The
volume or the area?
No, not volume. The surface.
Oh,
you can search.
Yes.
You can search for the surface in the internet of the sphere.
4 by r square.
Yes, excellent. So this is Gaussian surface of خلينا نكملها دي origin خلينا نسميها O sphere. اوكي خط كبير كده بس اظني واضح الحين. Okay. Now this is very important. Why I'm writing this? Because only at that surface, the surface doesn't mean it's a surface of a circle. انتبهوا شباب. This is a sphere 3D ثلاثي الابعاد. Okay. Okay. Now هذا نفس القضية راح يساوي كما خبرنا عمنا okay Gauss is equal to E enclosed divided by the permittivity of the free space. Everybody is agree? Okay, great. Now what we should do, just find the Q enclosed. لكن هنا راح يبقى عندنا شغل جديد شوية. ايش هو الشغل الجديد that we are looking for? You see now in the question, rho is not constant. But in the previous question, rho it was uniformly distributed. So rho here is constant. That means rho is not changing with R. يعني في كل سنتيمتر مثلا عندك 5 شحنات. خلاص ثابتة. طبعا كمثال هي ما سنتيمتر هي فوليوم. سنتيمتر كيوب خلينا نقول. Okay. In each centimeter cubed, okay, you have let's say 10 charges. Okay, so that's uniform. But the problem here, no, it is changing with R. If R is 1, then you have a different value. If R is 2, 3, 4, you have different values of rho. So in this case, if it's something is changing, as we said before, you should what? You should do the addition now. Okay? So you should add. Yeah, you should add all of these charges together. Okay? So Q enclosed in this case is adding sigma, so integration. Okay, of these small delta Q. What is small delta Q? Small delta Q, if we can take small sphere, okay, and this sphere, this is a sphere ball, 3D ball. So then we can add this sphere to the another one, okay, third one, fourth one. Okay. So now I'm adding up, summing up all charges in different volumes. Are you getting me? Okay. So this actually equals to adding all of these small delta Q. Let's call this one to understand what is delta Q. Delta Q, that's in delta V, the small delta V here. Okay, I want to add all of these delta Q. So that means I should know the rho that I am have been given, but it's changing actually rho. This is why I want to sum all of these rows. But because this is delta Q in that small volume delta V. So rho delta V, actually rho delta V, it gives me delta Q. Okay. Okay, until now, So far, so good. Okay. But we know that this is a volume of what? Of a sphere. We should know what is the volume of a sphere. Now we are looking, يا شباب, volume of a sphere. قبل شوية كان هذا إيش؟ كان هذا surface, يعني هذا area. Don't mix up. Okay? So why I'm looking for a volume of a sphere? Because the charges distribution in a sphere shape, okay, or volume. So volume of a sphere, we know this is just 4/3 or 4/3 by, and then we have r to the power 3. Okay. Okay. From here, we are not looking actually for full volume. We are looking for small dV. How can we get dV? Now we want to get small portion of volume, but we have volume, so we should differentiate this equation with respect to r. So we have dV dr, and that's, well, gives me very easy. We know that this is constant 4/3, and here by, and then we differentiate with respect to r. So these are constants. We're not touching this. So r cubed will be, about 3r to the power 2. This is not integration. This is differentiation. هنا اشتقاق وليس تكامل. Okay. طيب أنا الحين ما باغي dv على dr. I'm looking only for dv. So that means dv equals to يا شباب نفس الشيء. طبعا تروح 3 مع 3 صح؟ يطلع لي 4 باي يا شباب r squared multiply by dr. جبنا المقام هذا اللي تحت جبنا فوق. Okay. Okay, moving slowly to make it clear with you. So what I'm preparing now, I prepared dv, which is this one. I know rho from the equation, so now I can get q enclosed. Let me change the color حتى تحسوا بالحيوية والجمال. Okay, solving these problems. نختار اللون الأحمر يا رب مش مشكلة. Okay, now q enclosed equals to integration of rho is just rho naught, as we said, r over r capital, multiplied by dv. dv is just 4 by r squared into gr. Okay. You see now we are integrating. Some of these things are constant, so we'll take it out. And then we are integrating from 0, because this is the 0 point, the origin, up to the maximum. What يا شباب? This is a very important question now. ليش هذا السؤال الآن مهم؟ لأن هذا يفرق أنت الحين تبحث على خارج ولا داخل. So you ask yourself, does شو السؤال؟ Does the Gaussian surface اللي أنت اخترته يحيط بكل الشحنة، بكل المادة الأصلية؟ إذا كان الجواب نعم، إذا لازم تأخذ كل الراديوس مع المادة الأصلية. Okay. So in this case, we know that the original sphere starts from 0 up to our capital R. Okay. So we'll take it from 0 to capital R. Why is that? Because I want to sum all Q enclosed. Are these Q's are enclosed? Yes, they are enclosed by the Gaussian surface. Okay. So let's do the mathematical easy part, which is rho naught. Okay. Divided by capital R. These are constant, and then we have here 4 by. Okay. Okay, outside, and then we have the integration from 0 to r. Now we know this is r into r squared. This will be r cubed. Yeah. Okay. And this will gives us rho naught, or 4 by rho naught. That's fine. Okay. Over r. And here we have in the square bracket here, we have r to the power 4 over 4. Well, this is the result of the integration, but we are integrating from 0 to r capital. Yeah. Okay, that's fine. Now we know that there is 4 here, so 4, we'll go with 4. And this is r capital, and we are using the integration from 0 to r. So we substitute with capital R first. This will be r to the capital 4, sorry, capital R to the power 4 divided by r here. So then the result will be rho naught. Okay, we have pi here. Okay, r to the power 3. Okay, and this is what this is. Don't forget that this is Q enclosed. This is Q enclosed. Okay. Okay. We know that this is not the end of the solution. We are not looking only for Q enclosed. We are looking actually for E. So we should substitute here. Okay. We should put Q enclosed here, and we know this is 4 pi r squared. So we know that this is. Let's bring that one from there. So E into 4 pi r squared equals to and Q enclosed divided by epsilon naught, and this will be Q enclosed just by rho naught into r cubed. This is rho naught, okay, which is constant, divided by epsilon. Okay, and you know from here pi, and here we have pi. Okay, so this is the surface, Gaussian surface, and this is the Q enclosed, and we have here 4. So 4 and r squared will be down here, and at the end of the day we have E. Okay, will be equal to rho naught. Okay, r square, r capital cubed divided by 4 r squared epsilon naught. Okay. Now let's physics talk. Okay. So you see now the relation between E, okay, the electric field, outside. This is outside. This is where r is larger than or equal to r. Okay. So r is larger. Okay. You see, after we go outside, we can see as we increase r small, r capital is fixed. It's not changing because we know that this is the radius of the sphere. But here we have the r small is changing more than r capital. So as we increase this, this one will become less and less and less. But the relation is not like before because this is r squared. It's like y equal to x squared. You know this result. You know this kind of formula. But in this case, it's y is equal to 1 over x squared. Okay, so this is the relation now between them. Okay, so keep this in mind. If r is equal to r capital, again, you should substitute r capital instead of small r. Okay, let's do that. So let's say, we get in different color. Okay. So if r small is equal to r capital, this implies E equals to rho naught, okay, r cubed divided by 4 by r capital square. Why? Because r is equal to r capital into epsilon. Okay. Now you can see this one can goes, and we have only one r at the top here. Okay. And this will be again rho into r, sorry, into capital R, and this is over 4 epsilon. Okay. Okay. So we are just repeating the thing that we did like before, but now with a sphere. So nothing is big different now, but we understand as we go far away, okay, we are departing, going out of this original sphere, the amount of the electric field will be reduced, okay? And we'll see inshallah the relation after we finish this one for the inner side. So the second part now speaks about what? When r is less than or equal to r. What does it mean? R small is less than. That means, okay, we are looking inside the original sphere. Okay, so again, we have this purple sphere, very beautiful purple sphere, but we have been asked to find the electric field inside. So we'll choose any point, let's say this point here. So this point here, we call it Z, and any point. Okay. This point here is like this point, like any point at this surface that we have been choosing. وهذا السيرفس احنا نسميه Gaussian surface. Okay. So this is imaginary, تخيلي. أنا اخترته. أي شخص اختاره. Okay. And the small surface, it has small r. احنا عارفين إنه الأوريجينال sphere عندها كم؟ عندها capital R. الكابيتال R يمثل ماذا؟ large sphere, and the small r representing the imaginary sphere that we are drawing. Why we are choosing sphere in the Gaussian surface? Why? And why we are choosing small sphere here? Because we want both of them to be in symmetry. Why is that? Because we want to see that at the boundaries of that imaginary sphere, the electric field is the same. Okay. So we'll do the same thing as before, but just we look for R, which is related to the Gaussian surface, or maybe it's to the volume of that sphere. So let's do it again. Now we know that this is 4 pi. Okay, 4 pi r square. This r square, which is the small one, this is the Gaussian surface. Okay, so the Gaussian surface of the small sphere, not the original sphere. And this is multiplied with E, as we said. Okay. And this usually equals to Q enclosed divided by epsilon naught. Okay, that's very good. But we know how can we make Q enclosed? Can we use directly this Q enclosed from here? Can we go ahead and say, oh, I think we did everything and it's easy, it's here. Yeah, I'm asking you now, students. I don't want you to sleep yet. Can we use just directly this Q here? Where is the Q? This one? Can we use this directly here?
Yes, we can.
تخلوني استغمض.
No.
No. Why is no? No, yes, it is no.
Because we take R small inside
حد يبرد
the,
لي فؤادي شوي. حد يقول لي why it is no? Yes.
because we take the R small inside the Gaussian surface.
Right. We are taking our Gaussian surface is small with a small r. So we should ask ourselves, what are the charges or the distribution of the charge that enclosed within the Gaussian surface? يعني الذي يحدد الشحنات اللي موجودة داخل هو our Gaussian surface. في المرة الماضية لما قلنا إنه Q enclosed because the Gaussian surface was outside and all of the Q enclosed was within the original sphere. But in this case, the Q enclosed الشحنات اللي هي محطوطة داخل اوكي هي فين موجودة؟ فين داخل مو يعني داخل the Gaussian surface اللي احنا اخترناه. طيب احنا ايش اخترنا؟ اخترنا this small sphere. طيب small sphere هذه هل تغطي كل السفير الأصلية؟ No, it is only taking this sphere. اوكي؟ لازم تركزوا هنا شباب. طيب مو الفرق انه ايضا الدنسيتي مختلفة قاعدة تتغير مع الار. Okay? So in this case, as you brilliant students, okay, who just wake up, he said, I'm not saying just wake up. He is already, there, and he is looking for all the steps, and he is keeping himself sharp. Everybody's following the steps. It will be easy for him. But this is why I'm asking the questions, because I want all of you following the same thing. So Q enclosed, actually, yes, it's the same integration of delta Q. But we know that delta Q is coming from where? From the volume, or dV, into rho. Okay. And we know the dV that we are looking for in this case is what? Again, it's the dV. You're right. Okay. So we'll have to do that after we understand. It's the same actually as before, but the dV is changing. So this will be the same as integration of, now we said that's rho here, okay, into dV, okay. We know that dV, we got it from before. تذكروا وين كنا حصلنا dV? Okay, this is the dV. And yes, this is the volume of the sphere which is 4 by 3 by r cubed, and then we differentiate it, we get this. Okay. So at the end of the day, yes, we are using the same volume of the sphere because this is r capital. It was for the large one, but now we are using, yes, r small. Sorry, this is r small for the outer layer of, for the Gaussian surface, which is when r is capital, more than r capital. But also we still can use this volume with small r because our small r now is for the smaller volume, which is the smaller sphere. So in this case, dv it will be the same like this one, okay, which is 4 by r squared dr. 4 by r squared dr. Okay. Okay. Now we have everything with us now, so we will make the integration. We know rho is just rho naught r capital, and that multiply with the 4 by r squared dr. Okay. Okay. And we are integrating actually from where to where. هنا السر في الموضوع شباب. لا تنسوا شباب هذا Q enclosed equals to. Now we are integrating from 0 to شباب
R small.
R small.
Excellent. From R small. Okay. Okay. So make all the constants to the left side. So then we have rho naught, okay, over R capital into 4 by, okay, and then we integrate r cubed again from 0 to r small, and this is, as we said, this is Q enclosed. Okay, and this will gives us rho naught over r. It's the same thing, but in this case, what is the difference now? We are substituting with r small. هذا الفرق بس. يعني هنا بنحصل على and this is r to the power 4 over 4, but from 0 to r small, وهذا بالنتيجة راح يعطينا النتيجة التالية. طبعا 4 راح تروح مع ال 4 نفس القصة، يعني ماشي فرق، بس الفرق الوحيد انه راح يكون عندي هنا 4 rho naught into r to the، شوف r small هنا to the power 4 sorry the power 4 because it's the same, we are not changing that one, over r capital. Okay. Okay, very good. So far, so good. Okay. But this is Q enclosed. We are not looking for Q enclosed, we are looking for E. So we know E into, we have it here, 4 by r squared, okay, which is the Gaussian surface, 4 by r squared into L. Don't forget, so there is no L here. I'm sorry. There is no L here, so there is nothing like L here. Okay. This will be directed to equals to pi rho naught by, we'll go with the pi, okay, and then we have here r to the power 2, here r to 4, this will be to the power 2, okay, and from here we can get E equals to rho naught r to the power 2 over,
You forgot the
we
epsilon.
forget something here, we forget, I think, epsilon. Yes, yes.
Yes,
Thank you,
yes,
thank you,
yes.
thank you very much, thank you very much. Okay, you forget epsilon. عجبوني لما تكونوا جاهزين يعني. Okay, وانتوا دائما جاهزين إن شاء الله. For not r capital. I'm right. If I'm right, so that's okay. Hopefully everything is going very straightforward. Okay. الحين راح نقول إنه هذا اللي طلعناه في حالة متى شباب؟ r is less than r capital. Don't forget this. This is our condition list. We started from it. Okay. طيب لو افترضنا، راح نغير الخط حتى ما نتلخبط. لو قلنا if، نفس القضية راح نعيد if. ليش؟ هسه بنطلع نفس الاستنتاج. if r small is equals to r capital. okay. إذا كانت هذه تساوي هذه، إذا E راح تساوي إيش يا شباب؟ rho naught r capital squared, okay, divided by 4 epsilon naught r small. طبعا in this case هذا راح يروح مع هذا ويطلع لنا في النتيجة r naught epsilon naught sorry r capital over 4 epsilon. هذا الريزلت اللي طلعت عندنا الآن، هل هي نفس الريزلت اللي طلعناها آخر شيء هنا؟ Yes, it is the same. You see, rho naught r over 4 epsilon. Okay, so we are going smoothly, very nice, and we got actually the same results when r small is equal to r. But what is the physics behind all of these equations and numbers? Because in physics we are looking for meanings, okay, for situation. How can we understand this? Okay. This is the most important part in physics. It's not mathematics. How can we realize the meaning behind numbers? Okay. Now let's go and see when r. Let's start with this one. Okay. When r is less than r capital here, you see r is at the top here. Okay. So we are increasing r. R capital is constant. Don't look at this r capital. This is changing. So this is, it should be 0, 1, 2, until it reach r capital. As we increase this one, it's like a relation between y equals to x squared. You see? So as you put x equal to 1, so y is equal to 1. If you put x equal to 2, so y could be 4 times. Okay? So this is why we are looking for the result of the electric field as we go from the origin, from here, from the inside, outside we are accumulating more charges, so more electric field lines, so the intensity will be high and high. And you can see now the difference between this one and the previous question, because now we have the relation with x squared. So this is something to power 2, okay? So the variable now to the power 2. This is why we wanted to draw the relation. We should draw it like this. وخلينا نطلع، خلينا نكون أنيقين شوية حتى لو في النهاية ما مشكلة. Okay, ما شاء الله ما شاء الله. طيب, let's just take this one out. Okay. Let's choose another color. Okay. So now we know that this is the electric field and this is the radius, which is changing. Why are we putting small r here? لأن هي قاعدة تتغير. Okay. We know if we are starting from origin and then we reach here the big amount, the maximum amount of the radius, which is r capital, we see that the relation here at the beginning at r, actually we know that we have a certain amount of e. Okay. And we know the e here, which is e at r equals to rho naught capital R over 4 epsilon. We know this. Okay. But before that, before capital R, which is when you have small r is less than r, we know the relation is not linear. It is not going straight away. It is like drawing, you know, y, as I said, y equal to x squared, which acts like this, you know. So we are looking for this part only here. Okay. So this is why we're having the, I'm trying, يعني أحاول نخليه yes. Okay. Okay. So this is the relation with what? With r squared in this part here. It's not a linear relation. مثل ما شفنا في هنا في البداية لما كنا نتكلم في السؤال السابق. هنا كانت الريليشن directly مع r، هنا with r here. لأن المعادلة الأولى كانت كانت with r. You see? The result اللي طلعناها كانت with r, so e with r, so this is a linear. But in this case, no, it is not linear. Okay, this is why we have it in this formula. Okay, after r capital, we can see that is also when r is bigger than r capital, you can see the result here. This is when r is larger than r capital, we can see that the relation is between whom? Between e and 1 over r squared. إذا هذا كله constant إذا العلاقة between E and 1 over R squared. يعني في البداية كانت مع R squared، الحين راح تكون مع 1 over R squared، وهذا راح تكون أيضا يعني بالشكل هذا اللي I'm trying to نحاول نخليه smooth. Okay. This is the relation 1 over R squared. Okay.